Okay, this is problem number 6 from page 61 in your textbooks. I'm going to solve the function algebraically and graphically. Okay, so first I'm going to go ahead and solve this algebraically. What I need to do is isolate the absolute value. So I'm going to subtract 1 on both sides of the inequality. That leaves the absolute value of x minus 2 is less than or equal to 4. Okay, so now that that is isolated, I can determine if this is an and or an or. Okay, so because of the direction of my inequality, it's less than, that means that this is an and. Okay, so because it's an and, when I rewrite this, I'm going to keep it all together. So go ahead and drop the absolute value bars. You have x minus 2 less than equal to 4. Over here on the other side, your inequality less than equal to, you'll place that on the left side as well, but then make this a negative 4. Okay, so this 4 here, you have a positive 4 here, and then you have a negative 4 over here. Okay, so now we're going to go ahead and solve for x. We'll be adding 2 to all 3 sides. Okay, negative 4 plus 2 is negative 2, less than equal to x. Bring down your less than equal to. 4 plus 2 is 6. Okay, so how you would say this is x is greater than or equal to negative 2 and less than or equal to 6. Okay, so the mouth is open to the x. So x is greater. Here the mouth is close to the x. X is less. All right, so let's go ahead and solve this graphically. All right, to do that, what you do is you take the first part of your inequality and make that equal to f of x. So f of x is equal to the absolute value of x minus 2 plus 1. All right, and then the second part of your inequality, you're going to make that equal to g of x. So g of x is equal to 5. So what we're going to do is we're going to graph each one of these separately. Okay, so graphing f of x, the vertex is positive 2, positive 1. Okay, so 2, 1 vertex. Your slope, we're getting that from in front of the absolute value bars, 1 over 1. So rise 1, run 1. Okay, I'm continuing that slope. Okay, an absolute value function is symmetrical, so let's go ahead and repeat the other side of symmetry. All right, and then go ahead and draw my lines. Okay, I'll put my arrows. Okay, now we're ready to graph g of x. G of x is equal to 5. So let me make that blue. All right, so with the graphs, let's look at the points of the intersection. Here at x is negative 2. And then over here, the x for this intersection is positive 6. All right, so let's go back and look at the function f of x and g of x. Okay, this is f of x, and this part is g of x. And we would say that f of x is less than or equal to g of x. So f of x, the pink one, is less than the blue one. So what's happening is it's talking about this part right here, the pink that is less than the blue one. This is the pink part that is less than the blue part. So you're describing all the x values between this range. So between starting here, all of this, and stopping here at the 6. So you would say that the x values are equal to negative 2 equal to 6, and all the values in between. Right? So that's what we've described right over here algebraically. X is greater than or equal to -2 and less than or equal to 6. Right? So we've solved this algebraically and graphically.